Hello and welcome to this solution video. This is paper 1-2 Pure Mathematics 1 AS level, October-November 2022. If you like this video, please share with your friends, click on that thumbs up icon and subscribe to my channel. This exam was written yesterday only, so I am preparing these solutions without a marking scheme. So I use mostly mental math, or I use calculator for only complex calculations. So please, if one digit is here or there, do not complain. Please look at the methods I use. They are guaranteed correct. Alright. Question number 1 says point A and B have coordinates 5, 2 and 10, -1. So if this is the line A, B, the coordinates here are 5, 2 and 10, -1. Find the equation of the perpendicular bisector of AB. So this will be the perpendicular bisector and we have to find equation of this one. Equation of any line is y minus y1 equal to mx minus x1. So we don't need to replace y and x because they are any random point, general point on the line. We have to replace x1, m and y1. x1, y1 are the points on the line. So we can find somehow this point, we will find them by finding the midpoint of line AB, and those coordinates we will use in place of x1 and y1. So let's do it. So the x1, y1 coordinates will be 5 plus 10 divided by 2 and 2 minus 1 divided by 2. Yeah, this is how we find midpoint of two points. So I added 5 and 10 divided by 2. So we get here 7.5 and 1 over 2, 0.5. So the points x1, y1 are 7.5 and 0.5. Rather, let me write 15 over 2 and 1 over 2. This will help me because equation in decimals will be odd. So y minus half x minus 15 over 2. What is left? M is left. And we don't know the gradient of this particular line. But what we can do that we can find the gradient of this line AB. So let me write here. Gradient of AB will be y2 minus y1 divided by x2 minus x1. Let me take this as y2, 2. So 2 minus minus 1 over 5 minus 10. So we get here 3 over negative 5. This is the gradient of this line AB. So the gradient of perpendicular bisector, negative reciprocal of what we got here. So negative, first of all, reciprocal of 3/5 is 5 over 3. And we change the sign, whatever is the sign is negative here, so we'll make it positive. So 5 over 3 is Rm, the gradient of the perpendicular bisector, and now we will complete it. So let me multiply here also by 2 and this is by 2. So that this becomes 2y minus 1 divided by 2 whole of it now, right? Similarly, I'll do here 2 and 2. So we will get here 5 over 3 multiplied by 2x minus 15 over 2. So now the advantage of doing so is that we can cancel this 2 and this 2. Right, and then we can multiply this 3, cross multiply here. Both of them are exactly rational and multiplying. So 3 times 2y is 6y minus 3 equal to 5 times 2x. Now it can multiply inside 10x minus 75. So since x is positive here, let's bring everything to the right side. So 10x minus 6y minus 75 and plus 3. This minus 3 comes here. So and let me rearrange again. 10x minus 6y minus 72 equal to 0, and since they are divisible by 2, we can divide the whole of it by 2. More than 2 also? 4? No. Okay. So we can write 5x minus 3y minus 36 equal to 0. This is the equation of the perpendicular bisector. Let's see what is B part about. Find the equation of the circle with center at A and which passes through B. So I'll have to draw a circle now. Center at A and passing through B will be a very big circle like this. Not a good one, but just to imagine and visualize, this is okay. So this is the center. All right. So 5, 2 and 10 minus 1. 10 minus 1 is on the circumference and A 5, 2 is the center. 5, 2, 10, 1. Let me do it again. So the radius of this particular circle will be 5 and 10 is x1, x coordinates, right? 5 and 10, let me write here. 5 minus 10 square plus, then we have 2 minus 1 square. Okay, and let's put a general, because for equation we need a general point also. Let's say the general point is here, not here. Otherwise you'll think that it is on diameter, which will give us the equation. So this will also be equal to the radius. So square root 5 minus x square plus 2 minus y square, and this will give us the equation now. Square root and square root can cancel on both sides by squaring both sides. So what are we getting here? 5 minus 10 is minus 5, so 25, right? 25. 2 plus 1 is 3, so 3 square is 9, equal to, the square of this will be a minus b whole square, a square plus b square minus 2ab. That's how we will use it. 5 square, 25, x square, positive, okay? Because our identity has positive, and minus 2ab, minus 2 times 5, 10 times x, all right, plus 2 square, 4, y square, minus 2 times 2, 4y. So 25 on left side and 25 on the right side cancel, and nothing else cancels. Okay. So 9 also I can bring it to the right side. So 0 will be equal to x square, y square, minus 10x, minus 4y, and now the constants. This was minus 9 which came to right, minus 9 plus 5 is minus 5. And if you want to rearrange this equation, it can be written as x square plus y square minus 10x minus 4y equal to 5. That is the equation of the circle. Question number 2. The first, second and third terms of an AP are this. So A is A, A2 is twice of A, and A3 is A square, where A is a positive constant. All right. Find the sum of first 50 of terms of the progression. What is the formula for sum of 50 terms? So it will be 50 divided by 2, 2 times A plus n minus 50 minus 1d. So we know A as an alphabet here and D is unknown to us. So we'll have to evaluate them first, then we can use this, right? So D is A2 minus A1, or just A, which is 2A minus A. This is how we get D. D and A both are same. But we have to evaluate them. We have to get a value. So that means a square minus 2a, a3 minus a2 will be same as what we got here, a2 2a minus a. This is also true, right? Because this is also d, this is also d. We can write d if we want, and we will get an equation for a here. So a square minus 2a minus 2a plus a is equal to 0. A square 2 and 2 4 plus a minus 3a. So a is taken common, a minus 3 is equal to 0. So this gives us a equal to 0, this gives us a equal to 3. And they said somewhere, yeah, where a is a positive constant, that means 0 is not accepted. This is the one which we will use, and now we know this, we can use our formula we wanted. So it will be S50 equal to 25 outside, then 2a is 3. 2 times 3 plus 49. 50 minus 1, 49. D is again a. We got, yeah, D is a. That means it is also 3. And everything is in numbers now, and now we can calculate it. So 25, 6 plus 1, 47. 25 times 153. And that will be how much? 5. 3825 is the sum of 50 terms of this AP. Question number 3. Find the set of values of k for which this has no real roots. No real roots means the discriminant b square minus 4ac has to be less than 0, right? And that's what we will do. What is a? A is 8. B is k, and c is 2, and that's what we will substitute here. So k square minus 4 times 8 times 2 is less than 0. So k square minus 16 times 4, 64 is less than 0. So we can write here k plus 8, k minus 8 is less than 0. And you might be wondering how, because we have another identity, a square minus b square. It is factored as a plus b, a minus b. K was already a square, 64 is also square of 8, and that's why I wrote this. Now this becomes a quadratic inequality, and to solve such an inequality we should there are many methods, but the best one will be this one. Just draw them on number line. So this is giving us a root of k equal to -8. This will give k equal to 8. Roots, not solutions, where they will cross this. And since its leading coefficient is positive, the graph, if I draw a quadratic graph for this, it will be like this. And if we want it to be less than 0, less than means negative, and this part is below 0 level, yeah, this is negative, and this one is -8, this one is 8. So our final answer is that k is between -8 and 8. We can't write equal sign because clearly we want less than 0, not equal to 0. And that's the solution of range of values. They said find the set of values. This is the set of values, -8 to 8. B, solve this equation, and it has something like this. So it is exactly the same. Can you see? 8 cos square theta minus 10 cos theta plus 2 equals 0, but this 10 was not here and k is not 10, so we will have to redo this. So let's assume that cos theta is y. So our quadratic equation becomes 8y square minus 10y plus 2 equal to 0. I can factor this. 8 times 2 is 16 and 8 plus 2 is also 10. So I can write 8y square minus 8y minus 2y plus 2 equal to 0. Let's take 8y common here. So it will be y minus 1 minus 2 here, y minus 1 equal to 0. So the two factors are y minus 1 common in both, 8y minus 2. Okay, let's write them together now. Y minus 1 will be equal to 0, or 8y minus 2 is equal to 0. This gives us y equal to 1. This gives us 8y equal to 2. So y is 2 out of 8, or 1/4. But mind it, y was not the question. Question was cos theta, which we assumed as y. So this gives us cos theta equal to 1. And this is our domain, 0 to 180. We have to find angle. So theta will be cos inverse 1. Whenever we have a situation where cos theta or sin theta for that matter are 1, 0 or minus 1, use a graph. You should know the common graph of cos. So this is 1, this is minus 1. This is how the graph looks like. And where is it 1? Is it 1 here? Starting point, it is 1 at the last. Here the angle is 0. Here the angle is 360 degrees, right? But our domain is up to 180 only. That means we can accept only one answer, and there's an equal sign also. That means we can take 0. So this gives us theta equal to 0, where cos theta is 1. 0 degrees is the only one. Now if I look the second one, y cos theta equal to 1/4. So 1/4 is somewhere here. So it will be before, this is 180, okay? This angle up to here is 180. That means we don't have to look beyond this. So this is the answer, but we don't know what is the angle here. For that we need to do some legwork. Because cos theta is positive, that means cos theta will be in first quadrant. And we can do theta equal to cos inverse 1/4. In second quadrant, cos is negative, so we can't choose it. Cos inverse 1/4. And by the time I use my calculator for this, I would request you to again click on that thumbs up. I'm the first person to solve this paper, and I'll be solving many more papers in future too. Subscribe to my channel and share this video with your friends. Spread the word out. Thank you. What I'm getting here is 75.5 degrees, and that is actually the answer. We don't have to do anything else. 75.5. That's the answer. So there are two answers for this particular question. Okay. Question number 4. Question number 4 says a GP now, this time GP, is such that the third term is 1764. For a GP, A3 is 1764. And the sum of the second and third term, sum of A2 and A3 is 3444. Okay, that gives us A2 clearly. So let's subtract this here. So A3 is 1764. I'm not reading the question yet because I want to know A2. Subtract. So this cancels out. A2 is 0861. 1680 is A2. Now find the 50th term they're saying. Okay. So in a GP, 50th term, A50, will be first term and then common ratio to the power 50 minus 1. This is how it will be. A to the power R to the power 49. We don't know A, we don't know R. So since we know A1, A2, A3, we know A2, 1680, we just got it. And A3 was 1764, little more than that. So we can find R easily here. R will be any term divided by the previous term. So 1764 divided by 1680. It will be 4, 4, 1, 4, 2, 0. So 21 divides 20 and 21. Okay, so we got R equal to 21 divided by 20. Since we know R, we can find A also. R is A2 divided by A1. Yes or no? So we know R, we know A2, we can find A. So this will give us what? 21 over 20 divided by A2. We got A2 as 1680 divided by A. And let's cross multiply. A will be equal to 1680 over, not 20, 1680 multiplied by 20 divided by 21. So 80 times 20, 1600. That is the first term, A or A1, whatever you like. And now we can just substitute them here. A50 will be 1600 multiplied by 21 over 20 to the power 49. My calculator says 17474.13301. Ideally, this should be the answer. I don't think it needs to be rounded off because we can't change a term, okay, to 3 significant figures. Question number 5. The graph with equation y equal to fx transformed to the graph with equation y equal to gx. Okay, after transformation it becomes gx. Okay, by a stretch of in the x direction means horizontal direction, okay, with a factor of 0.5 followed by a translation of 0, 1. No translation in x direction but a translation of 1 in y direction upwards. Alright, so the diagram shows the graph of fx. It is there and it becomes gx. Okay, so what is it? On this diagram, sketch the graph of y equal to gx. Okay, so first of all we should say that gx is transformed and it is 0.5 factor 0.5 in x direction. That means f will not be affected but the content will be affected, and we don't write 0.5, we write its reciprocal. So if it is x, it will be reciprocal of 0.5 written in front of it, right? And then the translation in x direction 0, that means we can close, we don't have to add or subtract anything to the x, but to the whole function which is y, there is a translation of 1. So gx equal to f2x plus 1. This is the one, and accordingly we will draw now. So you should know that x becomes x over k minus d and y becomes ay plus c. What is k? K is the coefficient of x. D is the horizontal translation, but there is no translation here, so that means this will be useless. And here A is the coefficient of f, the one which is vertical stretch or compression, there is none. So this is 1 in this case. Y will be the original y, and C is the vertical in direction of y. What is the translation? And this is plus 1 in this case. Let's write them one by one. So the x coordinate here is 0. And we have to use this x divided by k. K is 2. This is k for us. So 0 divided by 2, and there is no translation, so 0 remains 0. I'm talking about x coordinates right now. Now the x coordinate here in this vertex is not about, it is 1. So 1 divided by 2 plus 0 is half. So this is transformed to half. Okay, next we have 2. So 2 divided by 2 plus 0, which is 1. And finally it is not finally 3 over 2 equal to 1.5 and 4 over 2 equal to 2. So x coordinates of these 1, 2, 3, 4, 5 are known to us now. Now we need to know y coordinates, and y coordinates are only two levels, 1 and 3, and we will use this. A is nothing but C is 1. So nothing means it is also 1. So it will be y if it is 1, okay, equal to 1. It becomes 1 times 1 plus 1, which is 2. Second level is 3. So y equal to 3. It becomes 1 times 3 plus 1, which is 4. Okay, and now we can draw the graphs. So x coordinate of this one was 0 and 1. 0 and 1. So this 0 and 1. So we'll get 0 and 2. 0 and 2. This will become 1 point. Next, this point is 1 and 3. So 1 became half and 3 became 4. So 1 became half is here and 4 here. Okay. Now similarly we'll have 2 and 1. So 2 becomes 1 and 1 becomes 2. So 1, 2. Next is 3, 3. So 3 became 1.5 and here 3 became 4. So 1.5 and 4. And then we have finally, okay, we can see the pattern now. So let me change the color for this. Okay. This red color is the graph of new transformation. Okay. Next thing they're saying, find an expression for gx in terms of fx, and that I've already written here. Gx is f 2x plus 1. Okay. What next? Question number 6. Question number 6 says the equation of a curve is 4x squared plus 20x plus 6. Express the equation in form of, okay, completing the square method where a, b, c are constants. Okay, so 4x squared plus 20x plus 6 are to be converted to vertex form or completing the square form. So first we should take 4 common out of this. So first two terms only, x squared, and if I take 4 out of 20, rather divide 4 out of 20, so we'll be left with 5x, leave some space and then write the remaining plus 6. Okay, I've left this space to add something here, and that will be we'll add always add, okay, half of this square, 2.5 square. Add this here, and it is not for free. We can't just add like this. We have to subtract the same. So 2.5 square is 6.25, and because of this 4, effectively we added times 4. 6.25 times 4 is 25. Actually we added 25, not 2.5 square, which is 6.25, because of this multiplying with 4, effectively 25 was added, so we have to subtract full 25 outside, not inside. And now we will complete this square, which will be x plus the sign is taken from the middle one and 2.5 from the last one, and square comes out, minus 19. This is the format, and we can say that a is 4, b is 2.5, and c is negative 19. All right. Hence, solve the equation, this equal to 45. Hence means we have to use what we got in previous part. Otherwise, we can solve it otherwise. But we have to use what we got in a part. So 4x plus 2.5 square minus 19, which is the left side here, will be equal to 45. Let's bring this 19 to the other side. 4x plus 2.5 square is 64. Divide both sides by 4 so that this 4 goes from the left side. X plus 2.5 square is 64 divided by 16. Square root both sides now to get rid of this square. So x plus 2.5 is plus or minus 4. Yeah, square root of 16, both positive and negative. This gives us our answer. X plus 2.5 is equal to 4 ones, and x plus 2.5 is equal to negative 4 ones. So what does this give us? X equal to 4 minus 2.5, which is 1.5. This is our first answer. X equal to negative 2.5 minus 4, which is negative 6.5. That's the solution of B part. Question C part, sketch the graph. Okay, for sketching the graph, I will need axes. Let me draw them. So axes are ready. This is origin, this is x-axis, this is y-axis, and we know the vertex of this particular equation because this was the vertex, right? This gives us vertex. How? The opposite sign of plus 2.5 is negative 2.5. So negative 2.5 is the x coordinate of the completing the square bracket. That x coordinates of the vertex, and negative 19 remains negative 19. This becomes our vertex, negative 2.5 and negative 19. So negative 2.5 somewhere here and negative 19 somewhere. Let's say this is the one, or rather let me give some space. So I'll put it here. So negative 2.5 and negative 19 are the vertices. Now we need x and y intercepts. So let's do the y-intercept first because it is easy to calculate. Well, for y-intercept, we put x equal to 0. On y-axis, everywhere x is 0. That's why we put it here in the main equation. So y equal to 4, 0 square plus 20 times 0 plus 6. Zeros are 0, so y 6. Positive 6. Suppose it is here. 6. This is our y-intercept. What about x-intercepts? For x-intercept, we will put y equal to 0. That means this equation equal to 0. 4x square plus 20x plus 6, which will be equal to 0. And 24, it's better to use calculator to get these two values. So we can use our calculators where we put a equal to 4, b equal to 20, c equal to 6, and we get our answer. What do we get in mind? Let me do it. The smaller one was minus 4.679, almost minus 4.7, and minus 0.321. Okay. So minus 0.321 somewhere here, minus 4.7 somewhere here, and now we can just join. This is minus 4.7. And this is the graph. If we want to trace it completely, and this will be the parabola of this particular quadratic equation or function. Okay. Next, question number 7. Question number 7 is asking us to prove the identity, this one. Okay. To prove the identity, they should merge first. So what will we do? For merging, they must have same denominator, and their denominators are not same. So when denominators are not same, what do we do? Suppose we want to add 2 plus 3 and 3 over 5. So we multiply this by 5 up and down, correct? And we multiply this 3 up and down. That's what we'll do here. We'll multiply this first term of the left hand side. This is left hand side I'm concentrating on. And I have prepared a video on many identities. I will put a link in the description. Please watch that video. It will help you to prove identities in future too. So I'm multiplying by sine theta minus cos theta to the first term. Now the second term, cos theta over sine theta minus cos theta. And again I will multiply it by the denominator of the other one, which was sine theta plus cos theta, and same will multiply denominator as well. So sine theta plus cos theta. Now if you notice, exactly same now, yeah, denominator, and they are of the same in the question where we had k in previous questions, a plus b, a minus b was a square minus b square, right? This is the identity we used in one of the questions. Same we are going to use here. It is a plus b, a minus b format, so it will be, denominator will be sine square theta minus cos square theta. That's it. If I multiply these two, and these two will give me the same thing. Now sine theta times sine theta is sine square theta, sine theta times minus cos theta will be minus sine theta cos theta, plus cos theta times sine theta, and cos theta times cos theta. Now look, they are exactly same, these two. We can cancel them out. Sine square theta plus cos square theta is 1. 1 over sine square theta minus cos square theta. However, it does not match with what they want. They want this. So don't worry. We can do what? We can divide both sides by, let's divide it, 1 divided by cos square theta. Both of numerator and denominator I am dividing by cos square theta. In place of writing it wholly cos square theta divided, I am writing under each one, which is allowed, right? So 1 over cos square theta, according to an identity, is secant square theta, correct? Sine square theta over cos square theta is tan square theta. Cos square and cos square cancel, minus 1. And secant square theta, according to another identity, is 1 plus tan square theta, or tan square theta plus 1. This is right hand side done. Okay. B part is there also. B part says hence means we have to use this one. Hence find the exact solutions of this. Let's see if it is exactly same. Sin theta, yeah, it is exactly same. Yes, okay. That means in place of this right hand side, we can write what we just got, this one. So this is equal to 2, right? And now we can do cross multiply this here. So we are left with what? Tan square theta plus 1 is the numerator left here, but denominator multiplies. 2 tan square theta minus 2. Okay, so now I can combine the tan squares together. So, or rather, let me bring this tan square to the right side and this minus 2 to the left side. So it becomes 1 plus 2 on the left side and 2 tan square theta minus tan square theta. Why did I do that? Because otherwise it would give me negative on both sides. So it's better to do this. So 3 is equal to 2 minus 1, just tan square theta. To get rid of square, let's do square root and plus and minus both. Yeah, square and square root cancel. So we get tan theta is equal to plus and minus square root 3. The domain they have given in radians is 0 to pi, and it is plus and minus both. So tan is positive with all other ratios in the first quadrant, and it is negative in second quadrant. So these two are the ones which will give us answer, and theta is tan inverse square root. This will give us the acute angle. Use your calculator, you will get that it is pi over 3, 60 degrees. So write pi over 3 on both sides, and finally you will have your answer. So the first answer will be theta equal to pi over 3 itself, the first one from 0 degrees. This is the line and this is our answer. Second answer will be this to the second line here, but it is not reaching pi. It is pi by 3 lesser than pi. So that's what we will write, pi minus pi over 3, which is 2 pi over 3. So these are the two solutions of this equation. Let's move on to the question number 8, which is this. Equation of a curve is such that the first derivative is this. The curve passes through 3 and 5. Find the equation of the curve straightforward. So what will we do? We'll just rearrange it. dy equal to 3x to the power half minus 3x to the power negative half dx. That's how we can do it. I did this dx went and joined others on the right side. So now we have no denominator. So to get the equation of the curve, we'll integrate both sides. Integration of dy is just y. The integration of 3x to the power half will be 3x to the power half, and we will add it by 1 and divide by the same new exponent. Similarly, 3x to the power minus half will be plus 1 here and negative plus 1 here, and then plus c. Okay, let's simplify this. Y is 3x to the power 3 over 2 and 3 over 2 there, but I will adjust 3 here and 2 I will write on numerator. 3 and 3 cancel out. Minus 3x to the power positive half divided by half, so 1 times 2 here. Okay, and then we have c. Y equal to 2, okay, minus 6 x to the power half plus c. Equation of a curve is not complete without getting the value of c, and for that we will use the point they have given us. So y is 5 in that point. 2 to the power 3 to the power 3 over 2 minus 6 plus c. All right, now 5, and if you break this into two parts, 2 to the power 3 to the power 1 times 3 to the power half. Can I write like this? Because 1 plus 3 over 1 over 2 will be 3 over 2 again. Yes, I can break it like this. So it can be written as 6 3 to the power half, which is exactly this. That means these two get cancelled out and c is 5, and our final equation of the equation becomes 2x to the power 3 over 2 minus 6x to the power 1 over 2 plus 5. This is the solution of this equation. Okay. Find the x coordinate of the stationary point of this particular function. So for that, what will we do? We will go back to our previous part, and there they are given first derivative. For a stationary point, first derivative has to be equal to 0, and it was 3x to the power half minus 3x to the power minus half, and that's what we're going to do here. 3x to the power half minus 3x to the power minus half. This was dy over dx, which has to be equal to 0 for stationary point, because this is the gradient. Gradient at stationary points is 0. The smaller of the two is minus half. The exponent, we'll take that one common with 3. 3x to the power minus half. So how much more is this? Let me show it here. X to the power minus half multiplied by x to the power 1 is x to the power positive half. Yes or no? That means if out of this x to the power half, x to the power minus half is gone, that means x to the power 1 is remaining. And that's what we'll write here. X minus, and this is already out, whole of it, so only 1 is left here, equal to 0. So what do we get? 3x to the power minus half is equal to 0, or x minus 1 is equal to 0. It gives us x equal to 1. They're saying find the x coordinate of the stationary point, that means there is only one. This one will not give us. Why? 3 over x to the power half is equal to 0, and cross multiplies here, 3 becomes equal to 0, which is not true. That means this one is useless. This is not going to give any solution. This is the one. They said x coordinate, we got x coordinate as 1. Let's see what next. State the set of values for x for which y is increasing. Okay, so we already know that x equal to 1 is a stationary point. Yeah, that's what we got in first part. But if it is a maximum, minimum, we don't know. So if it is a maximum, this is how the graph will look like, and this at this point x equal to 1. At minimum, this will be x equal to 1. But we don't know which one is which. So let's do what? This was our dy over dx, correct? Let's put a number greater than 1. That means on the right side. If it is positive, this is the case, because positive means it's increasing on the right side of 1. If it is negative, this is the case. Okay, so let's put 2 in this. So 3, rather let's put 4, because 4 has a square root, so it will be easy for us to do. 3 times 4 to the power half minus 3 times 3, and there is x also, right? Oh, there was x also here. X to the power minus half, so x is 4. So is it positive or negative? 3 times 2, 6 minus 3 divided by 2, 1.5, 4.5. Positive. That means this is the case. X equal to 1 is a minimum, and our answer is that x should be greater than 1. Are they saying increasing, right? Not equal to, okay. X is greater than 1 when it is increasing. This is not the case. This is the case. After 1, it increases at x increases. Alright. Function f and g are defined as this, okay, where a is a constant. Okay, x is greater than 0, and for this x are all real numbers. Find an expression for g f x. Okay, g f x means g is outside and fx is inside. In other words, we can substitute it by the value of fx, which is 1 over x plus 1 over x, and substitute it in g. In place of this x, now we write x plus 1 over x, and then we have plus 1. Find the expression. This is the expression. Do we want to open? Let's open this if they want it. Ax plus a over x plus 1, that is g f x. Alright, what next? Next time they say given that gf2 is equal to 11. So in place of this x, we have 2 now. Find value of a. So gf2 will be a2 plus a divided by 2 plus 1 equal to how much? 11. So 2a plus 0 half a, right? 2.5a equal to 11 minus 1. 2.5a equal to 10. So a is 10 divided by 2.5. 4 is the answer of this one. Okay, given that the graph of y equal to fx has a minimum when x is equal to 1, explain whether or not f has an inverse. So it has a minimum, right? Point as 1. So what does this mean? That means when x is equal to 1, just like previous question rather, it is a minimum. That means it was going down, and after 1 it started increasing. There is a turning point here. That means after 1, what happens that if I draw any horizontal line, 1 y will have 2 x's, isn't it? 1 y will have 2 x's. So to have inverse, the function has to be 1 to 1. Means one x should have one y, right? And that is not the case here. So that's why there is no inverse for fx. Okay? What next? It is given instead that a is 5. Find and simplify an expression for g inverse fx. Totally different one. So we will do, first we will find g inverse x and then we will substitute this. So what was gx? Gx was ax plus 1, right? And a is 5 now. So gx is 5x plus 1. So g inverse, for g inverse what will we do? Let's write inverse. For inverse, x becomes y and gx becomes x. That's how we write inverse, and we have to isolate this y now. So it becomes x minus y equal to 5y and divide 5. So this becomes g inverse x, which is x minus 1 over 5. And now find and simplify an expression for g inverse fx. That means in this now we will put g inverse x plus 1 over x. In place of this x, these are going to be there. 1 over x minus 1 over 5. So they want to simplify also. So this is not going to, because this is a x, this is a reciprocal, these are constant. So I don't think there is much more we can do. We can just write x over 5 plus 1 over 5x minus 1 over 5. Yeah, 5 divides all three of them on the top, and this becomes an expression for this. All right. Explain why the composite number fg cannot be formed. The gf, we just did gf, right? Earlier it was gf was possible, for fg is not possible. So f and g inside ax plus 1 plus, but it's possible linear inside this. So let's try it here. Ax plus 1 over ax plus 1. Okay, because of this, the domain of gx is whole of it, even less than 0 and 0 also. It's a linear, right? So what was that part? That was E part, I think. Let's see. Yeah, E part. So let's write E part answer here. Since range, yeah, this is domain given here, but it's a linear graph. Range of gx, which is a linear function, is x, not range we are talking about. Y is an element of all real numbers, but this domain, this range will become domain for, which will be x is an element of real number for f, but it is not possible because x is only more than 0, not even equal to 0, which is out of the domain of fx. That's why fg composite function is not possible. Okay, we have one circular measure question now. What do they say? The diagram shows cross section of RASB, okay, or the body of an aircraft. The cross section consists of sector OARB, this one, big one, and these two lines. So okay, it is 2.5 is the radius with center O, PASB, radius 2.24, center P, angle is 2.3 pi and 5/6 pi given, and alright. Find the perimeter of the cross section of RASB. RASB. Perimeter we need. Okay. So let's find perimeter this with the help of this radius and this angle, and then find this arc with the help of this radius and this angle, and we'll get our perimeter, the sum of the two. So perimeter will be ARB arc plus ASB arc, and we know that arc length is r theta, radius of that sector multiplied by the angle it is subtending on the center. So ARB, radius is 2.5 for this, so 2.5 multiplied by theta, but theta is on this side, whether arc is on the opposite side. So we need this angle on the opposite side, not this 2/3 pi. So we will subtract this 2/3 pi from 2 pi, because the whole circle is 360 degree. In radians it is 2 pi. So we will write 2 pi minus 2 pi over 3, and that will become our arc length. Now ASB, radius is 2.24 rather, and the angle will be 5/6 pi only because we are using this, and the angle towards this arc is 5/6 pi. And that's it. If we put this in our calculator, I'll get my answer. By the time I do this, I would request you to hit that thumbs up icon again and share this video with your friends, because this is the first time it is being answered. And subscribe to my channel. I'll be answering more videos in future. Thank you. What I got is 26 pi over 5, or in decimals. Did they say decimal? Correct, to 2 decimal places they did. So it will be 16.336. So we'll write 34 meter. That is the perimeter. And this is A part. That means we will have B part as well, which is to find the difference in the area of the two triangles AOB and APB. Okay, AOB and APB. AOB, this big triangle, and APB, small triangle. That means if we subtract, this is the area we will be left with, right? If we subtract the smaller triangle from the bigger triangle. Okay. So the angle, let me write here, area of a triangle is half AB sine C, where C is the angle between the two sides of the triangle. And let's talk about the first triangle, RASB, no, not RASB, AOB. So triangle AOB, its area will be half, and I will take 2.5 here, radius, and 2.5 here because they are same. So it will be 2.5 multiplied by 2.5 sine an angle. Which will I take, this or this? Because triangle is this way, so we'll take 2/3 pi, unlike the previous part where we took the other side. 2/3 pi. Let's put whole of this in our calculator, and we get our bigger triangles area, which is 1.45, not 1. Which comes out to be 2.70632. Now triangle, the other one, APB, half, but the radius this time is 2.24 and 2.24 sine 5 pi over 6. What I'm getting is 1.2544. So the area, difference in area will be 2.70632 minus 1.2544, which is equal to 1.45192, or round it off to 1.45 meter square. What's next? This one. Find the area of the cross section RASB, giving your answer to one decimal place. RASB. This whole of this we want to find area. So let's plan this first. Can I find the area of this major sector? Yes, I will find this one first. Then I will find the area of this sector, which is below. This middle area, this one, is not part of both of them, right? But we just found it, 1.45. So we will add the area of this one, this sector, and this 1.45, and we'll get the area of the whole shape, cross section, right? This is what we're going to do now. So area of a particular sector, the formula should be known to you. It is half r square theta. That's the area of, let me write here, area of any sector is half r square theta. So we said that we'll add the area of the two sectors. So first will be half r square is 2.5 square, but theta is the major. Again, it is not the one which is inside 2 pi over 3. No, it is on the opposite side, because we want the area, this one. So we will use that angle, which is 2 pi minus 2 pi over 3. Then second sector was half, again r was 2.24 square, theta for that is 5 pi over 6, no need to subtract it from anything. And then we got this, let me write this, 1.45192. These three we will add and we'll get our answer. So this I get as 25 over 6 pi, then 6.568, and then 1.45192. So total it will be 21.1099, or round it off to 21.1 meter square. That is the total area. Question number 11 is here. I think this is the last question. Find the coordinate of the minimum point of this function. So for minimum point, dy over dx has to be equal to 0. So let's differentiate this. Dy over dx will be differentiation of 9 over 4 x square. 9 over 4 remains 9 over 4, but 2 comes in front and the exponent of x goes down by 1. Minus 12 and minus 12 only. Differentiation of 18 will be 0. This has to be equal to 0. We can cancel this. So 9 over 2x equal to 12. So x becomes 12 times 2 over 9, which is 24 over 9. And they're saying coordinates. They're not saying coordinate. That means more than one. Let's simplify this first. It is 8 over 3. And now we have to find y coordinate. Let's put it here. 9 over 4, y is equal to 8 over 3 square minus 12, 8 over 3 plus 18. 3 square is 9, so this 9 and this 9 cancel. 8 square is 64, divided by 4, 16. This cancels here. 8 times 4 is 32 plus 18. So 18 plus 16 is 34, minus 32 is 2. So the coordinates of minimum point, because this is the only one point we got. We got only one solution, right? So there is no need to test that whether it's minimum maximum. They're confirming it. Is R 8 over 3, 2. All right. Next is a big one. The diagram shows the curves the same, and there's another one. The curves intersect at 0, 18. So this is 0, 18 and 4, 6. Okay. Find the area of the shaded region. Okay. So let's draw a vertical line here, and they want us to find the area of this shaded region. What if I find the area under this curve, which will be this whole of it, right? Out of this whole of it, I will subtract the area under the second curve, which is this curve. This, if I remove from the whole, I'll be left with the shaded part. And that is exactly what I'm going to do. So to find the area under a curve, we have to integrate. So basically what I'm saying is that I will integrate the upper one, which is 18 minus 3/8 x to the power 5 over 2 from 0 to 4. The x coordinate here is 4. So 4. And dx minus 0 to 4, the second one, which is 9 over 4 x square minus 12x plus 18 dx. So let's differentiate them now. It will be easier. So 18, integrate them, right? Integration of 18 will be 18x minus 3 over 8 x to the power 5 over 2 plus 1 over 5 over 2 plus 1 plus c minus second 9 over 4 x cube over 3, then minus, it is minus, right? Minus 12x. 12x square over 2 plus 18x plus d. The constant here will be different. We can see 18x here and 18x here, and there is a subtraction in between. We can cancel them before doing anything. That will not be right. Why? Because, but yeah, we have same numbers here. We can do that, but let's not do it. Let's not do it. Okay. So now I will substitute 4 first. So in the first bracket, it will be 18 times 4 minus 3/8. This is 7 over 2, 5 over 2 plus 1. So x I'm taking as 4. So 4 to the power 7 over 2 divided by 7 over 2. So I have to multiply again. This cancels. Plus c minus. I have to substitute 0 now in this one. I have not gone to this one yet. 18 times 0 is 0. Okay, this also has 0, so 0 plus c. Okay, there was nothing more. So this c cancels with this c, and they are zeros. That means this is the only thing left here. Let's do that here. 9 over 4, this rather cancel here. 3 over 4, right? So 3 over 4 x cube, 4 cube. So this 4 will also cancel with one of the 4, so will be 4 square, left with 4 square here. Then minus 6, yeah, 6 4 square plus 18 times 4 plus D minus this has 0, this has X also 0, that is 0, and then D. That means here also the second one was useless, so D and D cancel out. We are left with just this, and here we will write 18 times 4, 72. Then here we cancel something, yes, 8 times 7, 56. Let's not cancel, let's write here 56. And this will be how much? 64, right? No, 128 times 3. 4 to the power 7 over 2 will be 128, and I forgot to write 2. We have to write 2 again, that 2. Okay, now we can cancel. 2, 28. 4 times 7 and 4 times 3, 32. Okay. Done. This one is also done. C is gone, nothing else. Here, 3/4 times, no, 4, this 4 is gone. 3 times 16, 48, and because of this negative, it will be negative 48. And this negative are going to give us positive. 16 times 6, 96. 18 times 4 is 72 again. So that was cancelling. It's cancelling now. All right. So that is minus 96. Okay. Is it minus 96? No. It is minus 96 over 7 minus 48 plus 96. Just put this in a calculator and you are going to get 240 over 7 centimeter, not centimeter, units square. They are not specified if we have to convert to decimals or what. So let's leave it like this. Okay. What about the next one? The point P is moving along the curve 18 minus 3 over 8. Okay, the one which is going down in such a way that x coordinate of P is increasing at a rate of this. Okay. So y is equal to 18 minus 3 over 8 x to the power 5 over 2. Right? So this is x coordinate is increasing. When at a specific point we talk, we say that delta x is the change in x at a specific point. And how do we get that? First we differentiate this and convert dx into delta x for a very small amount. So dy over dx of this is 0. So no need to write it. Minus 3 over 8. Then 5 over 2 will come in front and it will go down by 1. So let me write now delta y over delta x for small change. Delta y is equal to minus 15 over 16 x to the power 3 over 2. Delta x divided by delta t. Let's divide delta t here and divide delta t here also. That they have given 2 units per second. So we have to involve time here. So if I divide delta t up and down, it becomes that one. So I can substitute it now. Delta t over 2 is equal to negative 15 over 16 and x they have given as 4 to the power 3 over 2. 4 to the power 3 over 2 is 8. So 8 times this goes, 8 times 2 is 16. And both have 2 denominators, we can cancel. So delta y over delta t, rate at which the y coordinate is changing is negative 5 units per second. That means it is decreasing continuously when x is 4. And let's see up there. This is 4 and it is decreasing here, and this is the moment they're talking about. It is decreasing minus 15 units per second. This concludes this solution video, which is a kind of world premiere. If you liked it, please show it by hitting that thumbs up icon. Share this video with your friends and subscribe to my channel. Thank you so much for your attention.